Physics. Topic: Current electricity. Part 2. Electromotive force and terminal voltage. The potential difference between the terminals of a cell when it is on an open circuit, that is when no current is drawn from it, is called its EMF. The potential difference between the terminals of a cell when it is in a closed circuit, when a current is drawn from it, is called a terminal voltage. Internal resistance of a cell. Every cell has a resistance of its own called internal resistance. The figure shows a circuit with external resistance R1 and internal resistance R. So the total resistance is R1 plus R. Current in the circuit is E by R1 plus R. Potential difference across internal resistance is I into R. Potential difference across external resistance is I into R1, which is also the terminal voltage. From this we can write EMF, electromotive force, equals terminal voltage plus the voltage drop across the battery's internal resistance. VR is the voltage drop across the internal resistance. So EMF equals V plus VR, which is equal to I into R1 plus R. From these formulas we can derive terminal voltage as E minus IR. Grouping of cells. Consider two cells of EMF E1 and E2 and internal resistance R1 and R2 connected in series as shown. The equivalent EMF and equivalent resistance of the combination is given by E equivalent equals E1 plus E2. R equivalent equals R1 plus R2. Cells connected in parallel. If the cells are connected as shown, then E equivalent by R equivalent equals E1 by R1 plus E2 by R2, where 1 by R equivalent equals 1 by R1 plus 1 by R2. Current in the circuit when N cells are connected in series is given by I equals NE by R plus NR. Current in the circuit when N cells are connected in parallel is given by I equals NE by NR plus R. Kirchoff's rules. Kirchoff's rules are the two fundamental laws used to analyze complex electrical circuits. They are based in the principle of conservation of charge and conservation of energy. Kirchoff's current law, KCL. Kirchoff's current law states that the total current entering a junction or node in a circuit is equal to total current leaving that junction. Mathematically, it is the sum of all currents meeting at a junction is zero. This can also be written as total current entering a junction must equal total current leaving. In the example shown, I1 plus I2 equals I3 plus I4. Kirchoff's voltage law states that the algebraic sum of all voltages around any closed loop in a circuit is zero. Mathematically, sum of all the voltages around any closed path is zero. In the example shown, V1 plus V2 plus V3 plus V4 equals 0. When applying KVL, it is important to follow a consistent sign convention. A common convention is to consider a voltage rise as positive and voltage drop as negative. Wheatstone bridge is a special circuit arrangement used to measure unknown resistance with extreme precision. There are 4 resistors, R1, R2, R3, and R4. Let us say R2 is unknown. They are arranged in a diamond shape. A voltage is applied across 2 opposite corners. A sensitive current detector, galvanometer, is connected between the other 2 corners, P and Q. When the bridge is balanced, no current flows through the galvanometer, the needle stays at 0. The balance condition is R1 by R2 equals R4 by R3. Rearrange this to find the unknown resistance R2, so R2 equals R1 into R3 by R4.
Video by Anand Mohandas.